So, in this lesson we are going to continue the interactions between the items, but also add the reaction of the character to some interactions and even combine some items. We will need to add some more assets to allow us to implement the dropping items in the world, for example, and also the new combinations. So, as before, let's start by updating the old script to accommodate these new features we are going to implement. Let's update the items database to include more parameters in each item and a function to quickly get the object using only the name. Open the items database script and add a mechanical and memory variable to the struct. Then, a public function that returns the item with the same name will input in the method's parameter. Public item find string search name. Item output item equals new item. For int index equals 0, index lower than items length index plus plus. If items index dot item object name is equal to search name, output item equals to items index and break. At the end, return output item. This find function expects a string with the name of the item. Then we run a for loop to go to each item until we find one where the name is equal to the search name. Then we return the item as an item type. Later, when we need to get an object, we call find name, and this function will spit out the item. The interactions we are going to program will need access to the hands sprite, but for now it is private, so set this variable to public. We will also have the need to clear the hand from outside of the inventory script, so let's code a function to do that. Clears the name and count of the end. Public void clear end, hand.name equals to empty, end.count equals to 0. Once we got this, we can also use it inside the script, so let's quickly call it instead of repeating the code. Here, where we put the item in the inventory, we clear the end, delete all these lines and just write clear hand, open close parenthesis, semicolon. Unity has a tilemap system that helps you build your levels and maps. We will use the tilemap system only for the ground sprites because it allows us to quickly paint the terrain in our map. Start by setting the new ground sprites. We have 3 grass and 3 sand tiles in this ground's main sprite. The pixel per unit for this one is 100, to make the sprite look larger. Once done, we need to create the tile map. Right-click on the hierarchy and add a 2D tilemap isometric object. This will create a grid object with one tilemap inside. Set the grid cell size to 6 by 2 and the order in layer of the tilemap renderer to -10. At this point, you can duplicate the tilemap and change the names to grass and sand. To paint the sprites into the grid, we will need a tile palette. You can find the panel at Window, 2D, Tile Palette. So, create a new palette, call it Grounds, set it isometric with the same size to the grid as before, 6 by 2. Save in a new folder called Palettes. Now, drag the main Grounds sprite to the palette and select a new folder called Tiles inside the palettes. After that, you have the 6 tiles available to use. Select one tile, make sure you are with the brush tool, select the correct tile map in the hierarchy and paint. Now select both tile maps and tag them as ground. With both selected, add a tilemap collider 2D and a composite collider 2D. Set the tilemap collider to use by composite. In the rigid body, put 0 to the gravity scale and constrain all axes. And in the composite collider, set the isTrigger option, the geometry type to polygons, vertex distance to 0.01 and offset distance to 0.2. These tags and colliders will be used later to detect the correct type of ground in each step sound. We are going also to use the tag to detect the ground when we put an item on the ground. This is done and you can play to see the integration with the rest of the assets. Looks nice, but we actually can't reach the sand. Maybe we need to make the camera follow the player. We are going to use Cinemachine to control our camera. You open the Package Manager panel and select Packages from Unity Registry. To solve our camera problem, search for Cinemachine and click on Install. Quote-unquote, Cinemachine is a suite of modules for operating the Unity camera. Cinemachine solves the complex mathematics and logic of tracking targets, composing, blending, and cutting between shots. It is designed to significantly reduce the number of time-consuming manual manipulations and script revisions that take place during development. This means all those scripts you need to make to control the camera properly are already done and in your project folder. You should read the manual of the Cinemachine modules if you want to learn more about it, but for now, I will just set up a simple interaction with the player and consider it done. So, add a Cinemachine 2D camera. This is not a camera, it's just a controller to the main camera. You can notice that we now have a Cinemachine icon next to the camera, meaning the Cinemachine virtual camera is in control. Select the virtual camera object and drag the robo to the follow field. Because this will make the camera follow the player, we can set the camera to a smaller size to better appreciate the sprite and animations, but also to force the player to explore a little bit more. In my case, 6 is a good relation of size and world unravel. In the body enumerator, you make sure you have framing transposer and you hit play. The camera should be following the character precisely. Let's just set up a different behavior so the camera moves a little bit more smoothly. Select Game Window Guides and save during play, so you can have some visual aid and you don't need to stop the playing to set the numbers after testing. I like to have a little damping in the X and Y axis in order to have an acceleration and deceleration in the beginning and ending of the movement. I also like to have a small dead zone where the player can move without bringing the camera, because this prevents motion sickness when you change directions a lot. So lens size 6, damping 4.5, dead zone 0.24. Let's continue developing other features. In the future, if you think the camera needs other adjustments, you can always edit these numbers. We can handle items inside the inventory, but we are still missing two important aspects: combining items in the inventory and picking or releasing items from the inventory to the world and vice versa. This script will be a little bit more complex than the others before. Not because we are going to learn many new different code stuff, but because it needs to deal with many actions and needs to be very organized. Create a new script, call it Interactions, and add it to the Robos prefab. Let's plan here the actions we need for the script to handle. We will start by coding the necessary commands to deal with a mouse click by using a raycast 2D, so we can detect the object where the cursor is. A raycast is like a laser light that starts in your eye, goes through the cursor and hits something in the scene. This will always report the object where the ray lands, but there is a problem. Raycast ignores the UI and will report whatever is behind the UI instead of the UI itself. To avoid this behavior, we will only allow the raycast to happen if the cursor is not on top of the UI. Let's start by coding a method that reports true or false if the cursor is on top of an object connected to the event system, which the UI is. Private boolean is mouse over UI, return event system.current.isPointer over GameObject, open and close parentheses. For this to work, we also need this library, using Unity engine.eventsystems. Now that we have a way of detecting the mouse over the UI, we can actually start by adding the mouse click detection and decision systems. So, inside the update, we code a condition to detect if the click happens outside of the UI. Button 0 of the mouse is the left button. This if statement being true means we gather the conditions to process the click. So let's store in a raycast hit 2D variable the target of the raycast we fire when we click. Get object from raycast collision. Raycast hit 2D hit equals physics2d dot raycast from camera main screen to world point input mouse position to vector2 0. The next step is to make sure we have hit something. Check if some collider was found. If hit.collider is not equal to null. As you may imagine from this statement, this will only work if the objects have colliders. Now we are in a point where we are sure about all conditions. We click outside of the UI and the raycast hit an object that has a collider. Let's then tell the script what to do with the object hit. First is to get the game object itself from the found collider. Get the game object from the collider found, game object clicked equal hit.collider.gameObject. To test, we can do a print interacting with plus object clicked dot tag. At this point, if you play and click on the ground or in an item, you should be able to see in the console the tag of the object. Now we have the tag, we can perform the appropriate action to that tag. To filter the tags, we are going to use the switch case statement. Switch, open parenthesis, object clicked.tag, close parenthesis, open curly brackets, default colon, break semicolon, close curly brackets. The switch case statement is similar to the if statement, but only executes the match case. Even if the work done changes the case, preventing multiple results. So, to better understanding these cases, let's code the ones we actually need. We have the case where we are picking an item. Case item, pick item from world, break. Don't forget the case is a test on the variable of the switch. In this case, the tag of the object we just clicked. Case ground, put item on ground, break. And finally, case player, character reaction to object, break. So now it should be more clear what is going on here. Switch tests the value of object tag. In case of that tag being item, we pick the item from the world and we break out of the switch. If it is ground, it's because we are putting something on the ground. And if we click on the player, it's because we want to interact with the player. So to pick an item from the ground, what code do we need to add here? Well, just a method. We will not put the code here to keep the house clean. So we call a method that has the code inside, and if in the future we need to pick up a tool instead an item, we detect that case and use the same method to pick it up. Pick item from the world, open parenthesis, object clicked, close parenthesis, semicolon. After the update method, code a new method called pick item from world, game object, object clicked, that is expecting the clicked game object. The first thing we do is to make sure we have an empty hand. If not, nothing happens and the mouse click dies here. But if we can pick it up, we put the item data in the hand. Inventory.hand.sprite equals picked object.getComponent sprite renderer.sprite. Inventory.endSprite.sprite equals to picked object.getComponent sprite renderer.sprite. Inventory.end.name equals inventory.hand.sprite.name. And finally, inventory.hand.count equals 1. At the end, remove the object from the scene. Destroy picked object. We also need access to the inventory to change it, so up here we need a variable inventory. Inside the start, we need to get the component. Inventory equals getComponent inventory. At this point, you should be able to pick objects directly from the world and put them in the inventory. This method is ready and you can close it in this minus sign next to the method's declaration. In the ground case, we will call put item on ground. Down here, we create the method to handle that. Comment performs the necessary actions to put one item from the hand stack to the world. Void put item on ground, open close parentheses, enter, open close curly brackets. To add stuff to the scene, we need to have access to the game object we need to instantiate. This means we need a reference to the database. Serialize field, items, database, IDB. Go to the Robos prefab and target the database scriptable object. Now, inside the put item on ground, we first check if we are picking an object. If yes, we get the item from the database. Remember the find function we called earlier? And from the item, we get the game object to instantiate. Then we get the mouse position on screen to instantiate the object at the same location. We decrease the count from the hand if we have more than one, but eventually, if we reach 0, we clear the hand. And this is the process of putting something on the ground. At this point, if you run the game, you should be able to put items on the ground. Just one if you pick it from the ground, but one at a time if you pick a stack from the inventory. Now let's add a command to the inventory script to combine stacks of the same item. Imagine picking one lithium and wanting to put on top of the lithium already in the inventory. In the item button method, add another else if to test another condition. The item has the same name, but the stack is not full. So, combine hand with inventory slot. Else if items slot.name is equal to hand name, while items slot.count lower than max stack size, items slot.count ++ hand.count -, if hand count is equal to 0, clear hand, break, and down here inventory UI.update UI. We will use a while loop that will run until the test condition is false. This means while we have space, we continue to subtract from the hand and add to the stack. But inside this process, we need to test if the hand is empty, because if it is, we need to stop adding items to the stack and clear the hand. It's easier to test if the limit of the stack is small, so reduce this number here. You should be able to combine but never go over the limit of the allowed stack. Let's then return to the interaction script to continue. Let's code the final case, which is the player. So, case player, character reaction to object. Down here we declare the method void character reaction to object, open and close parentheses, open and close curly brackets. If we are trying to interact with the player, the first thing to do is to get the item from the database to get the correct information about the item. Variable item found equal idb.find inventory.hand.name. The type of variable is generic because we cannot declare the item type in this script. The next step is to set an individual reaction to each item. Let's say plutonium will charge the battery. We can use a switch case to check every item name and operate accordingly. Many items will have a default operation. They will just affect the player's health and nothing more. This means we can code a simple reaction to be called every time an item needs to do that. After the character reaction method, let's program another one with a simple reaction. Void simple full interaction, float energy, float mechanical, float memory. Note the method is expecting 3 floats. This will be sent to the simple full reaction method when reacting. This means that this function will be very wide in its usage. Inside, we will just sum the values from the item to the player's health and keep the minimum and maximum limits if we go above or under them. Health energy plus equal to energy. If health energy is higher than 1, health energy stays at 1. If health energy goes below 0, health energy equals to 0. We can do the same thing for the mechanical and for the memory. At the end, we discount the item from the hand and test to clear it if there are no more items. Inventory.hand.count -, and if inventory and count is 0, inventory clear hand. Now that we have this done, we are just missing a reference to the character's health. Go up here and code serialize field, character's health, health. Now in Unity, drag the character's health scriptable object to the field. If you run, nothing will happen because there is no reaction done yet. So, inside the character's reaction to object method, add a switch case to check the item's name. Let's code the reaction to the plutonium and iron. As you can see, the item values in the database are just being sent to the simple reaction method, which executes the code. You can even send 0 instead of a specific variable to not affect that field. Let's say lithium has energy but doesn't react directly to the player. Now return to Unity and in the database set 0.2 to the mechanical in the iron item and minus 0.1 in the plutonium's memory. Also, you need to tag the Robos prefab as player and add a trigger collider to increase the area where the player can click. Add another polygon collider 2D as trigger and roughly set it around the robot. This means the iron, when consumed, will increase the mechanical health of the robot, and the plutonium, when consumed, will increase the energy but will also degrade the memory. The question is, how many interactions can you think of? Do you want or need a new one? Just add it to the list. We are performing a simple sum to the numbers, but the code can be more complex and do many different things. We are still missing another thing we can do with the items. How about combining two items and create a new one? Imagine combining plutonium and lithium in order to absorb the radiation and converting it into energy. This new material will not damage the memory and will have more power than the plutonium by itself. Other combinations could be, for example, copper and glass to improve memory by allowing it to regenerate the circuits. Many more combinations could be added, but for that to be possible, we need new assets. In the sprite editor, add this wafer item and this energy cell. Also set up the buttons for the interface. Then duplicate the plutonium twice and set up the new items in the duplicates. Note that interactions are dependent on the collider, so we will need to expand the collider to the entire body so we can click on it. So after these ones, also do it to the others. This will make clicking the object a little easier, but also collecting them a bit more unrealistic. Now let's code the interactions. We test the emptiness of the end in the switch case to run the correct method from here. If inventory.end.name equals empty, pick item from world. Object clicked. But if you don't have any object, else if inventory end name is different from empty, combine items, object clicked, and then break. I guess the logic is simple here. So let's then create this combine items method to operate the combining. Void combine items, game object, clicked object. We send here the object we just clicked. We are assuming we already have something in the hand. And the first thing we need is to get the names of both items to eventually test if there is a combination. We can extract the name from the sprite, but there is a trick to keep the code simpler. We can set up the combinations directly with the sprites. And then we just need to compare the sprites, not the names. Sprite item1 equals object clicked dot get component sprite renderer dot sprite, and sprite item2 equals inventory dot hand sprite dot sprite. Now we have item 1 and item 2 with the correct sprites, and we just need to find the combination. But the question is, where are the possible combinations? Well, to allow the game designer to add more combinations at will and without changing the code, we will add those to the database. Go to the database script and add the following code. Declare an array variable to hold many combinations. Public combination array combinations. And then create the struct to hold the information about every combination. We don't have this type yet. System serializable public struct combination, and inside the combination we will have three things: one item, the other, and the output result. So public sprite item1, public sprite item2, and public game object result. And because we are comparing sprites and eventually we will need to instantiate a game object, let's just set those types in the variables to simplify the code later. Save all scripts and return to Unity. In the item count, you need to go 8 to accommodate the energy cell and the wafer. Don't forget that the energy cell has more power and no damage to the memory compared to the plutonium. And then create the combination you need. Add 2 and set the lithium sprite, the plutonium sprite, and the energy cell game object. Done. The other one is glass, copper, and if you join them, you have wafers. The setup is done, and we just need to finish the code that compares the sprites and spit a game object. So, after we have two items, we just loop through the database combinations to find a match. Loop the combination array to find a match. For int index equals 0, index below idb.combinations.length, which is the database, index plus. So for every combination in the database, we do a double test. First, if idb.combination index.item1 is equal to item1, and the second test, idb.combinations index.item2 is equal to item2. If both tests are true, we found a combination. So we just need to remove the clicked object from the world, decrease the count in hand, because we can be holding a stack, and then instantiate the combination result at the mouse position, which is the game object set in the database. So to remove is destroy object clicked. To decrease the count is inventory.end.count --. And if inventory hand count equals 0, inventory clear hand. To instantiate the database result, vector3 screen point equals input mouse position, screen point z equals 10, instantiate idb.combination index.result, comma, in which position, camera, main, screen to the world point, screen point, with which rotation, quaternion identity. After all, we break because the combination is done and we shouldn't continue the test. So, break. If we play, it would be possible to combine plutonium with lithium and copper with glass, but not the opposite. The item in the hand and the item in the world needs to be in the specific order. If we test the opposite, the combination will not work. This is because we are expecting to have the item 1 in the item 1 position all the time. So, to combine, no matter the position, we just copy the entire if statement and swap the numbers. Now the order is not important, and you can combine lithium in plutonium as you can combine plutonium with lithium. This code is so generic for combining two items that you just need to go to the database and add more combination. You just need to have the assets to instantiate and the sprites to set up the combination. Just for fun, let's test another combination. If you join gold with iron, you get, let's say, a rock. I guess you can imagine the possibilities now. You can even combine combinations. Let's say if you combine an energy cell with a wafer, you get another robo. This means that you, as a player, need to find materials to build elements that eventually will be used later to build other stuff. As you can see, this combination does not work very well because we have some hard references in the script and other robots will not communicate properly. Also, you will not play with more than one character, so that's not very important anyway. Maybe they can be NPCs, non-playable characters that can be your friends or your enemies. I don't know, any combination is possible. The last interaction in this lesson will be the step sound type changing according to the ground. We just need to make every step, so the prefab, detect the name of the sprite below and select the sound according to that name. Simple, right? So let's start by changing the sound variable to a struct so we can associate a name to the sounds. Also change the type and access level of sound to public and the new type you just created in the struct. Delete the entire start method, save and return to Unity. Now you don't have the sounds anymore. Set two types and configure them according to the names of the ground sprites. Lock the inspector and drag the sounds to the clips variable. This is done. Unlock the inspector and add a box collider 2D to the prefab. Set it to trigger and also to a very small size like 0.1. This is just to detect the ground. This collider will collide with everything, but in this case we will make a step sound only collide with the ground. To do that, we need to set up some collisions layers. In the layer menu, create one called step sound and another called ground. Return to the prefab and select the step sound. Now, on the grass and sand tile maps, set the ground. Last configuration is on Project Settings, Physics 2D. In the Layer Collision matrix, remove all the step sound relations except with the ground. This will make the step sounds collide only with the ground. Return to Visual Studio to finish the detection process. We will need some variables to hold information about the type of sound and if the player has already started to play the sound. String tag to play. Void onTriggerEnter2D, collider2D other. We make sure we are colliding with a ground tag if other.tag is equal to ground, and then we set the tag with the name of the ground sprite. Tag to play equals other.gameObject.name. We find the audio source, sound player get component audio source, and then we search for the sound type array. Int type index 0, for int type equals 0, type lower than sound length, type plus plus. If sounds type dot name is equal to tag to play, which means we found the correct set of sounds, type index equals type, and we break out. After we have the correct type index, we can use it to randomly set the clip to a sound clip from the corresponding array. SoundPlayer.clip equals to sound type index dot clips random range from 0 to sounds type index clips length. And then play the sound and allow the update to check if the sound is still playing to remove the step prefab at the end. SoundPlayer.play and check sound hand equals true. This is important because the collision happens after the first frame, and if we don't prevent the is playing being tested before the collision, the sound will disappear before even start to play. So in the update, also test if you can check the end of the sound. If check sound end sound player is playing blah 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 blah. Done. Save and play. If we walk to the sand, the sound will change and sound more appropriate. As you may imagine, if you have mud or snow or concrete or whatever ground you have, you just need to have the same sound library with the same names. And eventually the character will walk on top of those surfaces and it will sound correct. The main mechanics are done. The game can evolve, I'm sure, but the core system can be programmed like this. I believe you now have a broader idea about the implications in game dev. The rule is, if you need something, you need to build it step by step. Sometimes we need to rebuild to accommodate new features, but that is normal in this kind of exploratory game concept development. For this series, I will not evolve the game more than this. Yes, I know there are many things missing, but those things could be addressed in another series to complement and take this concept to another level. In the next lesson, that will be the last, I'm going to quickly make the trees and rocks appear more dynamically, build a simple structure to the splash screen, the start menu and the game over situation, and export and build a running executable of the game to publish online in a itch page. So I hope you learned something new with this lesson and I'm expecting to have you in the next one. Bye!